In this next section, we're talking all about graphing problems. And so for each of these functions slash equations, however you want to consider them, we're going to have to go ahead and graph all the ordered pairs to the function or equation. We're going to label all of our intercepts with the coordinates. Of course, always a good idea to label our graph with the equation. And if it's something that involves a solution set, maybe there's shading, let's go ahead and clearly label that. So let's start with this first one. Y equals x minus 3, that should be x minus 3 quantity squared minus 4. Okay, and so immediately when we see that x minus 3 squared, we're thinking that this is going to be a parabola. This is going to be some sort of U-shaped graph. So I sometimes toss a little U just off to the corner so that I know that going into it. And not only that, I think it's going to be the best idea for us to center our x values right around the x value 3. Because if x is 3, x minus 3 will be 0. And of course, 0 squared is 0. So that's going to be where our graph is centered around. So I'm actually going to make a quick XY chart. And what I'm going to do is I'm going to center my x values at 3, and then I will branch out from there to 4, 5, 6, maybe even 7, and 2, 1, 0, and negative 1. So real quick. All right, so if x were 3, 3 minus 3 is 0, 0 squared is 0, minus 4 is negative 4. So 3 comma negative 4. If x were 4, 4 minus 3 is 1, 1 squared is 1, minus 4 is negative 3. And we're going to get the exact same y value if x is 2 as well. Check it out, because 2 minus 3 is negative 1. Negative 1 squared is also 1. 1 minus 4 is negative 3. So what we're going to see here with these parabolas is that as we branch out from this center x value, we're going to have kind of symmetric y values. So if x were 5, 5 minus 3 is 2, 2 squared is 4, 4 minus 4 is 0. And I will leave it to you to confirm that's the same thing we get with an x value of 1. If x is 6, 6 minus 3 is 3, 3 squared is 9, 9 minus 4 is 5. And I leave it to you to confirm that's the same thing as an x value of 0. And last but not least, if x were 7, 7 minus 3 is 4, 4 squared is 16, minus 4 is 12. Okay, that's going to be a little off the graph, but you know what? Not a bad idea to at least put it there anyway. So now that we've got these ordered pairs, let's go ahead and graph them on our axes. Of course, let's go ahead and label them because that's always a good idea. So we had the point 3 comma negative 4. We had these guys. All right, and you can see it definitely looks like it's making a U shape just as we predicted. So I'm going to do my best to freehand it, and close enough. Now, always a good idea to label that with its equation. This is the graph of y equals x minus 3 quantity squared minus 4. Our x-intercepts are here and here. We happen to have two of them. Those are the points 1 comma 0 and 5 comma 0. And our y-intercept, we have just one of them, is the pair 0 comma 5. All right. Feeling good. All right, moving on. All right, now we've got an absolute value graph on our hands. And hopefully we remember that an absolute value graph is always going to be V-shaped. Maybe it'll be an right side up V, or maybe it'll be an upside down V. And perhaps you've already noticed that this negative sign in front of the absolute value, that tells us we're going to be dealing with an upside down V-shaped kind of graph. So it's nice to have that in mind before we even start making a table of values. Just like before, I don't think it's going to be a good idea to center our x values at 0. This x plus 5 in our absolute value bars, that tells me, you know what? Let's center our x values around negative 5. And from there, we'll branch out in either direction. So let's make a quick table of values. I'm going to have to zoom out a bit for this one. And let's center our x values at negative 5, and we will branch out from there. Negative 6, negative 7, negative 8, negative 9. So if x were negative 5, negative 5 plus 5 is 0, negative 0 is 0, 0 plus 2 is 2. If x were negative 4, negative 4 plus 5 is 1, absolute value of 1 is 1, negative 1 plus 2 is 1. If x were negative 3, negative 3 plus 5 is 2. The absolute value of 2 is 2, so we have negative 2 plus 2 is 0. And you know what? This trend is going to continue as we continue going into more positive, or rather less negative x values. And I leave it to you to confirm that we're actually going to have symmetric y values as we make our way up this table as well. So it's going to go down 1, 0, negative 1, negative 2. So let's go ahead and graph these on our set of axes. Of course, always want to go ahead and label these. All right, so we've got the point -5, comma 2, and then this guy's going to kind of branch out from there in both directions, and I think we probably have enough info to try and go ahead and, nice, I still have that line. Go ahead and try and make this graph. Let's go ahead and at least make this one blue as well. Gotta do that one more time. And always, 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 when we're done making our graph, don't forget, need some arrows on that bad boy. Did I do that over there? Yes, good. All right, let's label this graph with its equation. This is y equals the negative absolute value of x plus 5, all of that plus 2. Our y-intercept is the point 0, comma, -3. We once again have two x-intercepts, namely -7, comma, 0 and -3, comma, 0. And those are our x-intercepts. All right, not so bad, not so bad. All right, moving on. Okay, looking at number 19, 3y minus 7x equals 9. Immediately we should see, you know what? This is going to be the graph of a line. The equation is an equation that, when graphed, will be a line. We've got nothing to the second power, we've got no absolute value, we've got nothing funky. This is going to be a line. So I think let's put this into y equals and slope-intercept form. So to do that, let's go ahead and add 7x to both sides. 3y equals 9 plus 7x. Let's divide both sides of this equation by 3 in order to isolate that y variable. Y equals 3 plus 7/3 x. All right, so we've got our y-intercept of 3. So I always start by graphing that. Y-intercept in this case is 3. And I see that we have a slope of positive 7/3. So for every 3 units that x increases, so if we move 1, 2, 3 units to the right, our y coordinate will increase by 7. So 1, 2, 3, 4, 5, 6, 7. Wow, almost off the graph. And there it is. Awesome. And we can continue that pattern in the other direction as well. So for an x value decreasing by 3, 1, 2, 3, the y value will decrease by 1, 2, 3, 4, 5, 6, 7. Ba-boom! All right. All right, now let's go ahead and actually graph our line. Phenomenal. Let's make it a little bit more accurate, shall we? All right, that's good enough. I might as well make it blue. Blue. Phenomenal. All right. So there is our line of y equals 3 plus 7/3 x. We already know what the y-intercept is. That's 3. No need to label that. But what about the x-intercept? It looks like it's almost -1, but you know what? Let's not eyeball it. Let's actually find it for real. And to do that, let's use the equation. And you know what I actually like to do? Use the original equation to find the x-intercept. Right? The x-intercept happens when y is 0. You can just kind of get rid of that, -3y. If you want to find the x-intercept, when y is 0, you just get -7x equals 9. And hopefully, that's not so bad. You realize that the coordinate of our x-intercept must be -9/7, which is like -1 2/7. Does that kind of fit with what we graphed? Oh yeah, it looks like it could be -1 2/7. Heck yeah. So our x-intercept is -9/7, 0. Awesome. All right. Number 20. Oh, now we've got a linear inequality. Okay, so watch out. Inequality here. First things first, I like to solve and graph these inequalities by isolating our y variable. So let's start by doing that. So I'm going to isolate y by adding 20 to both sides. We have 20 plus 4x is less than or equal to -5y. We're going to divide both sides of this inequality by -5. And of course, once that happens, we need to remember, oh, this inequality is going to switch directions. So y is less than -4 minus 4/5 x. And if you really, really feel more comfortable having the y on the left-hand side of the equation, you can rewrite it. So that's the case. All right, now before we graph this inequality, let's graph the boundary line, BL, boundary line, if you will, which happens just by replacing the inequality with an equal sign. So the line y equals -4 minus 4/5 x, that's going to be the boundary between ordered pairs that are solutions and ordered pairs that are not solutions. So we've got a y-intercept of -4, so that's right down there. Let's go ahead and graph that. And the slope is -4/5, meaning for a 5-unit increase in x, 1, 2, 3, 4, 5, we'll have a 1, 2, 3, 4-unit decrease in y. And we will continue and extrapolate that pattern in both directions. So, all right, looks like that's all we can do right now. And note that since it was a less than or equal to inequality, we are going to keep this boundary line filled in to show the reader that, yes, the ordered pairs on this boundary line are part of our solution set. And since we have a y is less than or equal to, we are going to shade all numbers below that boundary line. I'm going to use a little highlight feature. Ooh, check it out. We're going to shade all of these ordered pairs below the boundary line, and this is our solution set for that inequality. And I'll even go so far as to actually write the words solution set, just so that the reader knows exactly what's going on. And you know what I would also suggest? Label that boundary line as well. That was the line y equals -4 minus 4/5 x. Really helpful for the reader to know which boundary line is which, especially if you have multiple graphs at the same time, which, if we look at number 21, we are going to have that. All right, so same idea. Let's start by graphing this guy in blue. And I'm going to isolate y. So I'm going to subtract 8x from both sides. 4y is greater than or equal to 8 minus 8x. Let's divide both sides of the equation by 4. No need to flip the inequality. Y is greater than or equal to 2 minus 2x. That shouldn't be so bad to graph. We're going to graph the boundary line first. The boundary line is just going to be the line y equals 2 minus 2x, and this will be the boundary between ordered pairs that are and are not solutions to this inequality. So here are some points on that boundary line. Let's go ahead and graph that boundary line. All right, primo. Let's make it blue. Fantastic. Oh, don't forget to label those axes, Barnes. Did I remember earlier? Yes. Good, 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 good. All right. All right. And let's see. Of course, it's going to be a full boundary line, and I'm going to label that boundary line y equals 2 minus 2x. And since it is y is greater than or equal to, we are going to shade above that boundary line. So I'm going to shade everything above with this cool highlighter feature, and might as well color code. Let's make this one in blue. Ooh, check it out. Very nice. Of course, on a final exam, I doubt you're going to be able to have a digital device, or maybe you'll have blue colored pens, but there are ways to let the reader know exactly what's going on as well. All right, and this guy, x is less than or equal to -2. Well, its boundary line is just the line x equals 2, and I hope we know what that looks like. That boundary line is a vertical line right at x equals -2. Oh, nicely done. Did I say 2? I meant to say -2. Excuse me. And since it is x is less than or equal to, we are going to shade to the left of that boundary line. So all these numbers, oops, excuse me, and let's label that boundary line, x equals -2. So all of these numbers to the left of that boundary line will be the ordered pair solutions to that second inequality. And perhaps you already know where the solution set is. The solution to this system of inequalities will be the ordered pairs that make both of them true at the same time. Those ordered pairs that are shaded in blue and red, namely these ordered pairs up here, continuing on forever and ever and ever. And so let's let the reader know that this is our solution set to that system of inequalities.